Lesson 37, I will use standard algorithm for two-digit by two-digit multiplication. So yesterday, or in lesson 36, we learned to use area model and partial products to multiply two-digit by two-digit multiplication. And today we're going to kind of be transitioning away from that into what's called standard algorithm, which is basically the strategy that your parents would use. All right, so in your math journal, go ahead and get it ready. We're going to do a couple of problems in your math journal today, so make sure you go ahead and label up today's date in lesson 37 so you'll have a good reference if you get confused. Okay, so let's take a look. This is basically what we did yesterday. 43 times 67, and over here you'll see my area model. I took 43 and I took 67. I want you to go ahead and over here on the right hand side, I want you to write our problem like we're going to solve it using partial products. 43 times 67. I want you to pause the video and see if you can solve this problem using what you remember from yesterday as much as you can. When you get finished, come back and see if you did it correctly. All right, so 60 times 40 would be 2,400. 60 times 3 would be 180. 40 times 7 is 28 tens or 280. And 7 times 3 is 21. So now these are all partial products. I bring them over here and I add them together. 2,400, 180, 280, and 21. So I'm going to add them all together. So I have 1, 18, 4, 5, 6, 7, 8, 2,881. So this strategy is partial products. I multiplied part of it at a time, added it together, and this is an area model. So we're going to take a look at what would happen if we transition to standard algorithm. So this is the exact same problem. So I'm actually going to go on dual screen here so we can see both problems at the same time. And this is what you just did in your journal. And this is the exact same problem, 43 times 67. But we can think of this as 43 times 7, which is what you have right here, plus 43 times 60, which is what you have here. Whenever your parents use standard algorithm, that's basically what they're doing. They're taking this problem and dividing it into two separate problems, 43 times 7 and 43 times 60. So we're going to use standard algorithm to do 43 times 7 and then 43 times 60, and then we're going to put it together. So if you remember from standard algorithm, 3 times 7 is 21, 4 times 7 is 28, plus 2 is 30. So 47 times 3 is 301. This is exactly what we would get if we added these two numbers together and we were doing partial products. 280 plus 21 is 301. Now we're going to do 43 times 60. So if you remember, it's 43 times 6, and we just add a 0. Okay? So I'm going to go ahead and put the 0 down first, and then I'm going to do 43 times 6. So 3 times 6 is 18. 4 times 6 is 24, plus 1 is 25. So I have 2,580, which is exactly what I would get if I added these two partial products together. So now I'm going to come over here and I'm going to list them underneath my expression, and I'm going to add them together. I'm actually going to do a little bit of erasing because I got a little bit tall right here. Okay, so now I have 301 plus, doing a lot of erasing today. All right, 2,580. I'm going to add this together. I'm going to go ahead and go full screen here. Okay, so let's go down a little bit. Okay, so I have 1. I don't know how my pen turned red, but that's okay. All right, 2,881. So if you go back and look, well, you won't have to go back because you can look in your journal, but that's the exact same answer that we got the last time. This time we used standard algorithm. Before we were using partial products and area model, but we got the exact same answer. Now there is a shortcut where you don't have to do two separate problems, which we'll be learning in lesson 38, but for this lesson we're going to stick with doing it kind of longhand until you understand how to do it. All right, so let's try one more. So this time we're going to do 24 times 36. So using standard algorithm, it's the same thing as 24 times 6 plus 24 times 30. Okay, so we'll do 24 times 6 first. So 4 times 6 is 24. 2 times 6 is 12, plus 2 is 14. So this is 144. I'm also going to write it over here, so I'll be ready to add. Right now I'm going to do 24 times 30. So you can see what I did. I just took 24, kept it as one number, and I did partial products on 36. Okay, and you'll notice I put the small number on top, and that's because when we take out the shortcut, you're going to do 24 times 6 first. All right, so now I'm going to do 24 times 30. It's the same thing as 24 times 3, and I add a 0, so I'm going to put the 0 first. 4 times 3 is 12. 2 times 3 is 6 plus 1 is 720. So this is 720, and when I add this together, I get 864. Okay? All right, now we're going to be ready for our problem set. So I want you to go ahead and write your name on your problem set, and you're going to notice that we're going to do a little bit of partial products and a little bit of standard algorithm both today in our problem set. So put your name on your paper and look at what it says. Solve 14 times 12 using 4 partial products and 2 partial products. Remember to think in terms of units as you solve. Write an expression to find the area of each smaller rectangle in the area model. Okay, so we have 4 times 10, which is 4 ones times 110, which is 40. And if you come over here, you can see they have 4 ones times 110, so that goes here. And then we have 4 times 2, which is 8. So 4 times 2 is 8. And then we have 10 times 10, which is 100. And we have 10 times 2, which is 20. So 110 times 2 ones is 20, and 110 times 110 is 100. So now we add all of these partial products together. So this is 4 partial products. We get 168. This is the exact same problem. The only difference is they did not separate 12. Instead of making it 10 and 2, they kept 12 together. So now we're going to do 12 times 4, which if you didn't know, you could always come over here and say 12 plus 12 plus 12 plus 12. I know that 12 times 4 is 48. So 4 ones times 12 ones is 48. And then we're doing 12 times 10. Well, 12 times 1 is 12, and I add my 10, so it's 120. Add it together, I get 168. So you can see this is the same strategy, it's just a little bit shorter. We did 2 partial products. Over here we did 4 partial products. This is leading into standard algorithm. Okay? All right, now it says we're going to do the exact same thing for 43 times 32. So we've got 43 and 32. So we do 40 times 2, which is 80. 3 times 2, which is 6. 40 times 30, which is 12. And then I add my 2 tens, so it's 1200. And then 3 times 30 is 90. So now, 2 ones times 3 ones, which is right here, is 6. 2 ones times 4 tens, which is right here, is 80. 3 tens times 3 ones, which is right here, is 90. And then the last one is 1,200. Okay, we're going to add that together. I'm going to be careful because you can see I kind of got my 9 and my 2 out of line. I don't want to be careful not to add that 2 to the 9. All right, so this is actually 8, 9, and 0, which is 17. And I have 100 and 200, which is 300. 1,376. So now this is the exact same problem. The only difference is we did not separate 43. We kept 43 together. So now we're going to do 43 times 2. Okay, so you could come over here and you could rewrite that. 43 times 2. 3 times 2 is 6. 4 times 2 is 8. So that is 86. And then we're going to do 43 times 30. Same thing as 43 times 3, but I'm going to add a 0. So 3 times 3 is 9, and 4 times 3 is 12. I get 1,290, and I'm going to add that together. 6, 8 plus 9 is 17. Carry the 1, that's 3. Now I have 1,376. So I could come back here and write my partial products inside here. Okay, so this is transitioning to standard algorithm. All right, now it says solve 57 by 15 using 2 partial products. Match each partial product to its rectangle on the area model. So we're going to draw an area model. So I'm going to go ahead and get me a rectangle going. And remember, we're only using 2 partial products. So my rectangle is not going to have 4 parts, it's only going to have 2. So if I'm doing 57 times 15, the number on top stays whole. So I'm going to put 57. And then I'm going to take 15 and I'm going to divide it into expanded form. Now I'm going to put the 5 on top because when we get ready to transition to standard algorithm, you're going to be multiplying the 5 first. So I think it's important to look at it that way. All right, so we're going to do 57 times 5. So over here, I'm going to do 57 times 5. So 7 times 5 is 35. 5 times 5 is 25, plus 3 is 28. So I have 285, 285. Okay, so this goes here. All right, now I'm going to do 57 times 10. I really don't have to work this out because 57 times 1 is 57, and I add my 0. So it's 570. 570. So this goes here. Now I'm just going to add these together. 5 plus 0 is 5. 8 plus 7 is 15. 2 and 5 is 7, plus 1 is 855. All right, now it's kind of taking us away from the area model. It says to visualize the area model to help you, okay? I'm going to go ahead and just draw it up here to kind of help us, but we don't, it says visualize, so we don't really have to. But if we have 25 times 46, that's 25 times 6, 25 times 40. So we've got 25 times 6, 25 times 40. Okay, so 25 times 6, 5 times 6 is 30, 2 times 6 is 12, plus 3 is 15, so this is 150. Now I'm going to do 25 times 40, which is really 25 times 4, but I add a 0, so 5 times 4 is 20, 2 times 4 is 8, plus 2 is 10, so I have 1,000. You have to be careful that you line these up. So now I'm just going to add 0, 5, 1, and 1. So I have 1,150. Okay, so over here, I'm not going to draw the area model this time. Let's see if we can do it without it. So this is really 18 times 2. So I'm going to put 18 times 2 plus 18 times 60. So over here, I'm going to do 18 times 2. 8 times 2 is 16. 1 times 2 is 2, plus 1 is 36. 18 times 60. It's really 18 times 6. You just add a 0. 8. 1 times 6 is 6, plus 4 is 10. So I have 1,080. Now I just add these together. I have 6, 11, 1, and 1. 1,116. Okay? All right, so now down here, we have to write it out for ourselves. They don't write it for us, okay? So this time it's 39 times 6 and 39 times 40. So if you feel pretty confident, go ahead and solve those two problems and add them together and then come back and see if you get the same thing I did. All right, so I've got 39 times 6, which is 54. 3 times 6 is 18. 18 plus 5 is 23. So that gives me 234. And then I've got 39 times 40. So I'm going to go ahead and put down my 0 because it's really 39 times 4. 9 times 4 is 36. 3 times 4 is 12, plus 3 is 15. So I have 1,560. All right, so now we're going to add these together and see what we get. All right, so 4 plus 0 would be 4. 3 plus 6 would be 9. And 2 plus 5 is 7. And then 1 would be 1. All right, I want you to try this problem all by yourself. If you get stuck, look back over here at what we've done the last 3 problems. And then come back and see if you get the same answer as me. Okay, so for this problem, we're going to do 78 times 3 and 78 times 20. So 78 times 3 would be 24. 7 times 3 is 21, plus 2 is 23. So we have 234 for 78 times 3. Now we're going to do 78 times 20. So it's really 78 times 2 and add a 10, so I put my 0 down. 8 times 2 is 16. 7 times 2 is 14, plus 1 is 15. So I have 1,560. I'm going to add these together. I get 1,794. Okay, so that is the last of your problem set. So today, remember, the whole point of today's lesson is to transition away from the area model and partial products into standard algorithm. Area model and partial products will always get you the same answer. The only reason why we're trying a new strategy is because this strategy is more efficient. So we're taking parts of the other strategies and we're trying to just make a few shortcuts so that we can do this a little bit quicker.